This is a video that's aimed at Year 11 engineers who are doing the controlled assessment task, where you have to design the base of the bike stand. You have to make the top, but you have to design the base. You don't have to make that, okay? But you do have to produce accurate drawings, and you have to make a manufacturing specification for a third party so they can manufacture it from your instructions and your technical documents. So this is a Park Tools stand. This is the Park Tools PCS 11. It's a decent piece of kit. This is. It's quite expensive. At the time I think I bought it, it was maybe £250. And you might think that's a lot of money, but I get a lot of use from this, and I've had it quite a few years and it's still in perfect working order. Might look a bit messy, but it's just used in the workshop. Okay, so it's not light, you know, it's not sort of portable device really. It stays in the workshop. If I have to take it anywhere, I have to put it in the boot of the car. It probably weighs about 15 kilos. It's made from fairly hefty material. Weight was not a driving factor when it was designed, okay? It's not one of the primary specification points for it. They didn't need to keep the weight down, I think. Let's have a look at the way it works, right? So it's got a base, and the base comes together like this. So it's got three legs made out of tubular steel. They unclip from the base and they pivot, look, on a little looks like an M6 bolt, and they swing up until a little sprung-loaded little button, a bit like what you'd find in a pair of crutches, goes onto a little ramp and then drops into a circular hole, and that locks that leg in place. If you want to unlock it, you've got to push the button down and it'll unlock. So it's just a no tools required operation. When you design yours, that's one of the key things they want you to think about as well. Same with this one here. So if I pull that one up and swing it up, that clicks in place. Okay, so it's not quite ready yet. I need to lower the whole of this stand and look for another little button on the upright leg. So push the button down the upright leg, drop that in place, and wait for the click when that goes in. Okay, so now my frame for the base is assembled. I've got these little locks on the side that I call cam locks. A cam, if you don't know what a cam is an eccentric, so it's a circle with a hole that's not through the centre. And when you rotate it, the lobe, that's the lumpy bar on the cam, pushes against the surface and clamps together. So that's clamped fully now. There is my base of my bike stand. So here's an important thing to think about: the shape of the base of the stand. Stability is really important when you're working on a bike stand. So what have they done to create stability? Well, they've given you legs that are almost 80 centimetres, 800 millimetres. So you've got a really wide triangular base there. The footprint formed by that triangle there, quite huge, and that is very important, right? Because this stand, when it's fully assembled to the correct height, is going to be, well, so I'm 1.7 something tall. You know, it's about 1.5 meters off the ground. So 1.5 meters off the ground. If you put weight onto that, now, so if I clamp a bike on that, there's quite a bit of weight there, but this stand is still stable. Okay, it's not going to fall over. I can move it around quite a lot. It's not falling over. This bike, it probably weighs about 10 kilos, maybe a little bit less, maybe 9 kilos, and that stand is well within its sort of functional capability. So that height, let's have a look why that's important, right? So it's all about something called centre of gravity or centre of mass. With this designed as it is, we've got no control of the fact that the mass is going to be quite high up in the structure. It has to be, because that's the height we want to work at it. And if I was working on something like an e-bike or a downhill mountain bike, something with a bit more weight to it than my bike, the centre of mass is going to be really high in the structure. The centre of mass needs to be in the middle of the footprint vertically. So if I hang a weight from the centre of mass, it should be hanging vertically in the middle of that triangle. If it is, happy days, we're in stable equilibrium, we call it. If it's not, then it's possible that we could tip it over backwards. Here's another thing that helps the centre of mass. This angle piece here is not vertical. If it was, I've got risk of toppling backwards. I'd be in unstable equilibrium, we call it. But as it is, look, it's designed so that that's leaning in to create centre of mass in the middle of the footprint. Pretty important feature to mention. Right, let's have a look at materials that have been used then. Okay, so we know weight's not an issue. So what materials have they chosen? Well, they've chosen to make the stand from steel, mild steel, predominantly because of toughness. They're not worried about weight. I mean, they could have used aluminium, some kind of fancy aluminium alloy, but it would have added a lot to the cost. and bearing in mind it's not designed to be moved around, it wouldn't really have added much to the design. So it's mild steel, fairly hefty wall thickness. I imagine it's probably going to be about 2 millimeters wall thickness. It's very, very strong steel tube, and it is tubular. So it's tubular for a reason. So tube is very stiff. If you try and bend a tube, they'll struggle. So it's tubular for the stiffness they require. The other thing with making it out of mild steel, of course, it's very easy to manufacture. So you can cut and shape things. So like for example, where they've created this strong section on the base there, that's not a casting or anything, that's all been welded and fabricated. So they've used a MIG or a TIG welder to weld in these gussets, these little webs in the corners to create strength. That little triangle appearing again for strength, all been welded together. So cutting, shaping, welding with mild steel is pretty straightforward. Okay. So yeah, a bit of drilling going on. There's not a lot more secondary machining on the actual stand bit though, I suppose. Maybe a bit more secondary machining on the clamp bolts and the pinch bolts, and a bit of turning going on the lathe. And there's a knurled finger bolt there, and the cam lock will have been manufactured using some form of secondary machining, I imagine. What other materials have been used? Well, a big component part is the black pieces here, which are made of polymer. Okay, so like in other words, plastics. The way they've been made, you can kind of look for clues as to how it's been made really, but like break lines on a mould. So these have been injection moulded. So essentially you're looking for a polymer which is going to turn into a liquid at a high temperature, and then it gets injected into a mould, and when it's gone cold it goes solid, the mould split, and out comes the component part. So polymers that we can use, well, there's lots of thermopolymers, the ones that soften when they get hot. This one here just happens to be one of the nylon family. They've chosen one of the nylon family because all the polyamides, all the nylons are very tough plastics, but this one is a trick polymer. It's a composite polymer, and it's I'm suspecting that this is nylon 12. Nylon 12 is a glass-filled polymer, and it feels like the same material they would use to injection mold screwdriver handles. So that's what I'm guessing. Okay, so it is resin fiber-filled nylon, which is injection molded. Very, very strong, very tough, very durable plastic polymer. Sorry, I should say, which is useful. Okay, what does this head part of the design do? Well, it gives me the chance to adjust my stand in a different way. You don't have to design this part of your bike stand, okay, but just as an interesting aside, on this one I can change the angle of it so that if I'm working on a bike and I want to lean it up a little bit, so I put this bike back in again. Look, this is a bike I'm building at the moment. It's a lightweight touring bike. When you clamp the bike in the frame, it's always good to clamp by the seat post. The seat post is a very strong part of your bike frame. This part here, you're not going to crush it. The middle section of the frame on the bike here, this is probably made of double butted aluminium alloy. That means the middle section is thinner walled than the ends of it, where they've had to weld it. So yeah, this is an aluminium frame. This is scandium alloy, it's called. It's hopefully quite tough and hard wearing, and very light. I didn't want to go for carbon on a bike because I'm going to be quite a lot of weight on it. That's not me, that's my luggage, by the way. Right, so unlock that. So I can adjust the angle of the bike if I need to. Talking about other materials, what else is there to mention? Oh, I guess the surface finish that they've put on this metal is quite important. When I bought it and I was looking at pictures of it on the internet, I did think it was galvanised. I should look more closely really. It's not a problem, but it's been powder coated, and in some places the powder coating has come off where I've probably been standing on it or something, and so it has started to rust in places, so I might have to give it a little bit of a respray to look after it. Yeah, we don't have to worry about the head part of it here. They're just asking you to design the base there that gives it stability. So I've got another bike stand that's in school, and I will do another video about that. You can compare and contrast and just basically magpie some ideas from it, but this is a particularly good one to have a look at. Alright.